Have you ever wondered how a huge, high-level law passed in Europe actually connects to a single, hands-on cybersecurity test on a server? Well, today, we're going to follow that exact path. We're going from international regulation all the way down to the code to see how real security actually gets built.
And we're starting right here. This quote from the European Union's NIS2 directive, it just perfectly captures the urgency of the problem. You see, we're not just facing more cyber incidents. They're bigger, they're way more sophisticated, and they're happening more often. This right here is the why that's driving everything we're about to talk about. So, with a threat like that growing every day, where do you even begin? Well, you start at the very top. You start with the new rules of the game that are completely reshaping cybersecurity across Europe. It's called the NIS2 directive. And the goal really is straightforward, but it is massive. Create one single, high-level security standard for the entire EU. It's all about replacing this messy patchwork of different national rules with one strong baseline to protect the whole market.
Now, this law isn't some one-size-fits-all mandate, and that's actually really smart. It categorizes organizations by how critical they are. So you have essential entities. For them, regulators are involved before an incident to make sure they're prepared and after one happens. But then for important entities, the approach is lighter. Supervision usually only kicks in after something has already gone wrong. It's a risk-based approach, baked right into the law.
And believe me, when the law says critical, they are not exaggerating. We are not just talking about tech companies here. This covers the absolute foundations of modern life: power grids, water supplies, hospitals, the banking system, and all the digital infrastructure that holds it together. The reach of this thing is huge. So, what does the law actually demand from them? Well, the obligations are pretty clear. Manage your risk, plan for all kinds of hazards, lock down your supply chain, and report big incidents fast. But here's the part that's a real game changer. The buck now stops at the very top. Management, the C-suite, is now legally required to personally approve and oversee all of these security measures. Okay, but a law is just words on paper, right? How does an organization actually turn that legal mandate into a real, functioning, secure system? What's the first step? And to answer that, we have to move from the law books into the design meetings. We need to see the blueprint, the framework, that companies use to actually build a system that can meet these incredibly demanding new rules. A really common blueprint for this is something called the Trust Services Criteria, or TSC. Now, the best way to think about it is not as some rigid checklist, but more like a flexible guide. It helps a company design the right controls for its own specific needs, which is exactly what a high-level law like NIST2 is asking for. The whole framework is built around these 5 core ideas. And you'll notice it's not just about security in the sense of, stopping hackers. It's a much more holistic view. Is the system actually online when you need it? Does it process data correctly? Is sensitive information kept secret? And is people's personal privacy respected? Altogether, these 5 things define what makes a system truly trustworthy. Let's just quickly break these down. Security and availability, pretty straightforward. Processing integrity? That just means the system does what it's supposed to do, accurately and reliably. And it's really helpful to see the difference between confidentiality, which is all about protecting sensitive business data, and privacy, which is specifically about protecting people's personal information.
And right here, this is where you see the connections snap into place. An organization takes a big, high-level demand from NIST2, like you must manage risk, and then it uses this detailed TSC framework to design specific, tangible controls that actually get that job done. This framework is the bridge from the legal what to the technical how.
But of course, having a great blueprint doesn't guarantee a strong building. Once the system is all designed and it's up and running, how can we be absolutely sure that the defenses we've built are actually effective and not just security theater? This brings us to our final and most technical layer. This is where the rubber meets the road. We're moving from theory and design to the real-world test, proving the system can actually stand up to an attack. The official name for this is an Information Security Assessment. The goal, as the National Institute of Standards and Technology, or NIST, puts it, is pretty simple. You use technical tools to actively find and confirm the weaknesses in your own system before an attacker does it for you. A really fundamental technique here is vulnerability scanning. Think of it like an automated first pass. A tool just sweeps your network, finds all the connected devices, and checks them against this huge database of known problems, like if they're missing a critical software patch. It's designed to give you a quick, wide-angle view of your potential weak spots. But how you run the test is just as important as what you're testing. With overt or white hat testing, the IT team knows it's happening. This lets you do a really deep, comprehensive check of everything. Covert or black hat testing is totally different. The IT staff has no clue it's coming, though of course management has approved it. This doesn't just test your technology, it tests your people and their real-world ability to spot and respond to a surprise attack. And the ultimate form of this is a penetration test, a pen test, which follows these 4 phases. First, you have planning, where you set the rules of the game. Then comes discovery, using those vulnerability scans and other tools to find targets. Next is the attack phase, where the tester actively tries to break in to prove the weaknesses are real. And finally, it all wraps up with reporting, to document everything so the organization can go and fix the holes. All right, so let's pull back from all those technical details for a second and put all 3 of these layers together. Let's look at what a single, cohesive strategy actually looks like. It really does form a kind of pyramid. At the very bottom, the foundation, you have regulation. That's the why. That's the legal mandate from NIST that forces everybody to act. In the middle, you've got a framework, like the TSC. That's the how. It's the blueprint for designing controls that actually work. And then at the very top, you have testing, guided by standards from NIST. And that is the proof. That's how you verify your design holds up in the real world.
And honestly, that's the most important takeaway here. You can't just buy a firewall, plug it in, and declare yourself secure. Real, effective cybersecurity is a continuous process that connects legal obligations, thoughtful design, and rigorous, constant testing. Each piece of this puzzle has to support the others. So we'll just leave you with this one question. Looking at this home model, from the law to the blueprint to the proof, is your own organization's strategy actually built on preventing attacks, or is it just waiting to react to the next one?